thank you again for the opportunity, and I'm going to be talking for this little while about the Real-Time Networks project, which is just about to be concluded. The Real-Time Networks project began some four years ago now. It is an Ofgem sponsored project under the Network Innovation Competition in the UK. And it has lasted, as I say, over the last 4 years. It's just about drawn to a conclusion. And later on in the year, there's going to be some form of dissemination event that will explain a lot about what the research has uncovered. Of course, with the current situation, that's a little uncertain as to how that's going to be held at this moment in time. So what's the project about? Well, there are many different aspects to the project, and really it is about understanding what is going on within lower pressure networks so that we can design those networks better, that we can understand how to operate those networks better. And so to that end, one of the major parts of the project was to install a test area within the southeast, I should say, of the UK, at SGN's area around Medway, and that required the installation of meters so that we can understand the flows and test our sort of various different scenarios that would come out of it. But that's actually not going to be the focus on what I'm going to talk about today. Alongside that, I should say that we also have developed a system that allows us to monitor exactly what's going on within that test area and to run different forms of analyses. That's what you're looking at there, some of the handling of data that comes in on ongoing basis. But the heart of what I'd like to talk about today, and I think our last speaker touched on it when they talked about the quality of data rather than the quantity of data. And it's that quality of data that I'm going to talk about in regards to gas demand modelling, and therefore the link to network modelling in general. And this was the key purpose of the project, to arrive at a detailed and accurate demand model that would replace the current system that is being used by gas distribution networks across the UK. That was developed some 30 odd years ago and is now well out of date and needs to be replaced, especially with the current move to more renewable types of gas coming into the system, and indeed renewable types of technology using gas and taking gas from the system. And therefore, this requirement was there to develop an approach to network analysis that would refresh, as it were, the way those systems are designed. But not just the lower pressure tiers. The concept is that in developing a demand model for the lower pressure tiers, we'd enable the higher pressure tiers also to benefit as a consequence of understanding better what is going on in those lower pressure tiers. And also, we wanted to extend the model to include what would happen with energy modelling, and I'll explain a little bit more about that later on, and also with different types of renewable technologies where consumers are taking and using gas in a different way. And so the model is about taking consumer data, and I mean by that simple address data and some basic understanding of the use of gas by consumers, taking consumer flow data in great detail for a small number of consumers that form the sample that we're going to use, and combining that with various forms of socioeconomic data which tell us about location and type of consumer. So this is the way we approached the problem. To begin with, we had to make a an estimate, as it were, of the different breakdown of consumers that might be possible. So that we would collect a sample of data from those consumers and really try to understand how those people use gas in great detail. And therefore, flow logging was installed on about 1,200 consumers across the southeast of the UK. And that data was collected for just 2 years. In the future, of course, that form of data collection might need to change. As more and more smart metering is installed, then the opportunity to actually install any other version, any other approach to collecting data becomes limited. And you've got this other opportunity to use data in a more readily accessible, hopefully, way, and a way in which facilitates the ongoing development of modelling. But that's for the future. For the project, we collected data on a 6-minute granularity, which is ideal for the UK, for Great Britain. I'll show you an example of what that actually looks like. Of course, a lot of the UK systems, especially the lower pressure systems, are indeed very low pressures. Many of the low pressure systems will operate at 30 millibar or even lower than that in some cases for quite a bit of the year. And therefore, the impact of any consumers can be great, and that drives us therefore to actually need to understand what's happening in quite fine detail. That's true for the UK, for other parts of the world, for other regions that perhaps don't use low pressure systems in quite the same way. Then these processes, this methodology, can be adapted to use half-hourly data or hourly data options. I think what's important, though, is that we actually do develop an understanding of the profile of use over each day for all types of consumers that are defined. So this is just an example you're looking at of a number of different days, a couple of winters ago, and you can see the very peaky way in which that particular gas consumer has behaved, and that's not unusual. That's the typical way in which consumers tend to take gas, with the boilers clicking on and off on a regular basis. It's only when you build up the picture of many different consumers of the particular type that you start to see profiles that then help you to understand what their general behavior is like. So how do we use that information? Well, we used it in a number of different techniques, statistical techniques that I'll again touch on in a moment: cluster analysis, discriminant analysis. And we used it together with a number of other sources of data. So the first one would be from SGN, our partner in this project, would be consumer data. So it's their record of their consumers, their addresses. And the particular concern with this is the annual quantity of gas that those consumers use. Now, for the UK, that's a standard measure that's coped with, as it were, within the data that's collected, and it is a useful measure that we have used within the modelling to actually be able to scale, as it were, different types of consumers against each other, so we know which ones are using more or less amounts of gas. It's a scaling device. Now, the other inputs there are from National Ordnance Survey. Now, the address-based information gives us location information. It does give some information about the type of consumer, but most importantly, it gives address and location information that helps us to be able to pinpoint where those consumers are. Then there's a couple of other sources of information that help to actually break down the type of consumer, including sort of house type, whether WFH is work from home indicator, which actually is quite important because it actually differentiates when somebody is not a business as such, even though they may say something industries. They're actually just somebody working from home. So it's that sort of level of detail that we want to collect, understand, and get it right, as it were, from the bottom up. That discriminant, the cluster analysis then is used to group those consumers into meaningful sets of consumers that we can then use within the modeling process. So cluster analysis gives us those groupings. We started off with an estimate of what those groupings would be, and that's really turned into those groupings that you see on the left-hand side there. Because discriminant analysis then allows us to be able to apply those groupings to all the population across the southeast in this case. So we know who they are, what they are, and we know where to place them. And that's a measure there of the sort of accuracy with which the model has produced. That there's an example of a 4-bedroom detached house, and in that case, you're looking at the results of a testing algorithm that we put together that tests the outcome of the model against many, many different conditions, many mixes of consumer sizes and numbers. And that red line wobbling about the middle shows the sort of level of accuracy that we've been able to achieve with that. Moving on, we're able then to classify that information, to address, match, and to allocate those consumers, all with data quality information. So we're able to say what a consumer is and have some information about the quality of that decision. So a weight of evidence approach using the different sources of data. Similarly, for allocation, a process is used to ensure that they end up in the right place on that network, that is the sort of network that you see illustrated there on the right-hand side. So what models have we produced? Well, the first one is a peak model, a peak 1 in 20 demand model. That's the standard of demand that's required in the UK, though for other areas it could be. So what that actually means is it's a 1 in 20 occurrence of that 1 year in 20 when that peak 6 load would occur. So it's an extreme reaction by consumers to the temperature that they are actually experiencing. And we apply that with variably across the network. So that means that we apply demand to a network, we take away demand, and that's the normal pattern of flow the way in which we demonstrate that within the network model. But to show the way in which different consumers are actually taking gas at different times, subtly different times perhaps, or maybe greatly different times if they're a totally different type of user, then there are compensations made across that network model. And that allows us then to reflect properly the way in which demand changes across there. Now, we've compared that information to the sort of demands that we were getting on the current modelling approaches that are used in the UK. And when you see that collectively at say, the condition that I refer to there, the Medway test area, that's something of the order of 26,000 consumers of various different types. And when you look at those as an overall group, compared to the current modelling approach, there's a 30% reduction in demand. Now you can see that that's not something to be sneezed at all. That's something which is going to motivate people to actually understand how that can be applied. Of course, at the other end of things, then yes, there is some decrease. There is some increase in pressure in demand, but overall, because of that dramatic reduction compared to the current approach, then overall pressure drop is reduced. And that's important for things like mains replacement, which is a key theme within the UK. Sorry. So that allows us to provide to the optimal design for for investment. Off-peak demand is another area that we've developed. You can see the sort of profiles of consumers there between different offices, pubs or shops operating in different ways. And that's been developed specifically really to enable us to operate the system better. That gives us an envelope, if you like, that we can define each different type consumer type that they will fall into. But there are some that will fall outside that. And that's where the real-time modeling comes into its own. That uses historic data. So what you're looking at here on the red line is the fit that we actually had for the model. So that's the off-peak model, if you like. The blue line reflects what they actually did. So we're able to use live data to be able to retrain that model to be able to give a better forecast going forward. And that's really where the real-time bit comes in. And so that is able to then enable us to optimize the sort of bottom-up forecasts that we can produce from this process. I'll quickly touch on some of the other ways that types of modeling that we produced. We know that consumers are developing or starting to use different types of technologies within their homes, whether it's hybrid sorts of heat pumps or other sorts of heat pumps, or even micro CHPs. So we conducted tests to see the way in which those types of devices might impact on the modeling that we developed. And we have indeed been able to model the sorts of impact that those would have in reducing peaks or changing the way in which the profiles across days would happen. One other types of modeling that we produced was that of looking at the energy that's involved in that's distributed through the system. Biomethane sites are currently required to propionate gas to a level that allows, in the UK, that allows them to comply with the required standard for gas to be distributed in the UK. Now, there are options being considered to actually remove that propionation, which means that the CV would vary greatly. And so we've developed methods that allow us to assess the impact of those changes in CV on lower pressure. So what you're looking at in terms of the dots are the feeds into the lower pressure system. So that's the MP system, the IP systems that feed into the low pressure system. And you can see where that type of gas ends up. So the output, as it says, is CV at points of interest across that system. Now, all of this is being developed to fit into one of our existing systems, the Integrated Demand System, IDS. That is a currently produced tool that handles consumer data and enables that data to be used within network analysis. And the plan is to be able, over a period, to implement the various different outcomes from real-time modeling within that system. So there would be business-focused services available to consumers, to distribution networks going forward that implement the best of all that comes out of the real-time network modeling. Now, I know I've not talked about machine learning as such, or an AI, but I think this approach to handling data and getting it right, as it were, from the bottom up, is a very important and critical step in actually being able to digitalize the gas industry going forward. And it shows, I believe, an optimized way of collecting, handling data, training data, so that we can train for a demand model that has the accuracy required to give the sort of benefits that we're looking at. Thanks for your attention, and I think we have some opportunity for questions.
Fascinating. Thank you very much, David. I think it would be so interesting to see how the demand varied across the different consumer types over the last 3 months and compared to an average.
Yes, every day was a Saturday, I think.
And I'm sure that's going to be a critical model going forwards as part of an energy transition as well, be it for hydrogen transport for energy or dosing hydrogen into our domestic gas supply. So I think there's going to be some very interesting questions coming through on the chat just now. We have one from Annie who says, how do you find the extraction of hydrogen from possible resources available in this integration module for gas monitoring process?
Well, I'm not quite sure how to answer that. I think I can say that I talked about biomethane just now as being an influence, and indeed at the moment the way that we have set up the analysis, it responds to biomethane. It could equally respond to hydrogen being input into that system, and we could equally as well track the impact of that. And I believe that's something that is probably going to be followed up on at some point. So hydrogen, we can cope with that. The introduction of that into that sort of system. I'm not sure if that answers the thrust of what that question is about, but I hope it deals with it.
That worked for me. Any further questions from the floor before we move on to our next presenter? I'm not seeing any come through immediately. I think it would be worth showing our appreciation again for Dave's presentation with the applause button. And thank you again, Dave.